Hi everyone, welcome back to my video. I am Dr. Hang Ding from IU South Bend. This video is part 5, which is also the last part of control structures in Java. In previous parts of control structures, I had covered two selection statements, the if and the if-else statements, and all three iteration statements in Java, including the while statement, the for statement, and the do while statement. In this video, I will cover the last selection statement, which is the switch statement. I will also cover the break and continue statements, which are related to the control of flow. And finally, I will cover logical operators, which can be used in any selection statements and iteration statements. Let's start with the switch statement, which is a multi-selection statement. Switch statement performs different actions based on the possible values of a controlling expression. This is the flowchart that is typically implemented by a switch statement. It's a special form of nested if-else statements in which every condition must be an equality comparison between the value of the controlling expression and a constant value. The switch statement syntax starts with the keyword switch, followed by the controlling expression in parentheses. The controlling expression must yield a constant value of the four primitive types: byte, short, int, and char. As of Java SE7, the expression may also be a string. Type string is not a primitive type and will be discussed later in another video. After the parentheses to the right of the controlling expression, switch statement consists of a block that contains a sequence of case labels and an optional default case. Each non-default case starts with the keyword case, followed by a constant value that the controlling expression may receive, then a colon, then a sequence of statements for that case. The default case starts with the default keyword instead of the case keyword and a constant value. The program compares the value of controlling expression with each case label. If a match occurs, the program executes that case statements. Its labeled case may end with a break statement. The break statement causes program control to proceed with the first statement after the switch, but you need not place a break statement in each case. If you omit a break, that case continues until a break or the end of the switch statement is reached. Here is an example of the switch statement in a simple calculator program. This program will ask the user to enter a simple arithmetic operation between two numbers and display the result of the operation. The user will enter the first operand of the operation into variable x, then enter an operator in terms of one of the four characters, plus, minus, asterisk, or forward slash, and finally enters the second operand into variable y. After reading the user's input for the arithmetic operation, the program uses a switch statement to determine which operator is in the operation. The operator character is stored in the variable op, which is of type char. So the controlling expression in this switch statement is simply the op variable. This switch statement then processes four constant values of variable op in the four corresponding case label: plus, minus, asterisk, and the forward slash character. In each case, it displays the value of x, variable op, y, and the result of the corresponding operation between x and y, where a plus corresponds to addition, a minus corresponds to subtraction, and an asterisk and a forward slash correspond to the multiplication and division respectively. For example, here is an output of the program where the user enters an asterisk for the operator. And so the first operand is 23.5, and the second operand is 10. So then it display 23.50000 address or multiply 10.00000 equal 235.0. So here we just want to print out the result with only one digit after the decimal point. This switch statement also has a default case, which is executed when there's no match with one of the four cases above. In the default case, it displays invalid operator. For example, when the user enters a percent size for the operator, it displays invalid operator in the output. There are a few notes on the syntax of the switch statement that you should be aware of. First, the switch statement does not test ranges of values. If you listed a range of value in a case label, such as K from capital A to capital D, like this, you could get a syntax error. Every value must be listed in a separate case label. For example, to cover cases from capital A to capital D, you would have to write case capital A, then case capital B, then case capital C, then case capital D. The second note is that each case can have multiple statements. Note that switch differs from other control statements in that it does not require braces around multiple statements in in a case. For example, in each case of the switch statement in the calculator program, you may have two statements before break. The first one is to assign the result of the arithmetic operation to the result variable. Then the second statement could be the same as the original printf statement, but replaces the arithmetic expression with variable result. As you can see, there is no additional braces added here. The last note is about the default case. Recall that the default case will execute when there's no match with a case label. But the default case is optional. If no match occurs and there is no default case, the program control continues with the first statement after the switch statement. Each case label in a switch statement can also be a named constant or a final variable, as long as that named constant has the same type as the value of the controlling expression of the switch statement. Java also allows you to define a group of named constants as an enumerated type or enum type because it is defined with the keyword enum. The constants of an enum type can also be used in case labels of a switch statement. As an example, consider this code fragment. The first line defines an enum type named color, which has three values represented by three named constants: red, blue, green. Note that since these are named constants, we use the all caps convention to name them. The first value in an enumerated type has an ordinal value of 0. The second has an ordinal value of 1. The third one has an ordinal value of 2, and so on. So the red value of the color type has an ordinal value of 0. The blue has an ordinal value of 1, and the green value has an ordinal value of 2. In general, the definition of an enum type starts with the keyword enum, followed by the type name, and then the list of named constants in braces, and ended with a semicolon. Once the enum type is defined, you can declare variables of that type just like you declare variables of any type. Here we declare variable C of type color. So C can only receive values listed in the color enum type. To access a value of an enum type, you write the name of the type, then a dot, then the name of a constant in the enum type. For example, to access value blue of the color enum type, we write color.blue. In this example, we also use a variable C as the controlling expression of a switch statement. Then we use the constants of the color enum type in the case labels of the switch statement. Most switch statements use a break in each case to terminate the switch statement after processing the case. Without break in the matching case, execution continues to subsequent cases after the matching case executes until a break or the end of the switch is encountered. This phenomenon is known as the falling through behavior. Forgetting a break statement when one is needed in a switch statement is a logic error. For example, consider this code fragment, which has a switch statement that attempts to translate a numeric day of the week to names of the day. The numeric day is stored in variable day, which is of type int. The variable day is used as the controlling expression of the switch statement. The switch statement has three cases corresponding to three values of day: 1, 2, 3. When day is 1, So in the case day is 1, it prints out Monday. In the case day is 2, it prints out Tuesday. In the case that day is equal to 3, it prints out Wednesday. But there's no break statement in any case. So when day is assigned to value 1, with the value 1, this switch statement actually outputs Monday, Tuesday, Wednesday instead of just Monday as expected. That is because all cases from the matching case and subsequent cases are executed. The break statement is not required for the switch last case or the optional default case when it appears last, because execution continues with the next statement after the switch. Sometimes in a switch statement, there are many cases that are processed in the same way. For example, assuming that letter grade has been declared to be a string, and we write this switch statement to display excellent when letter grade is A plus, A or A minus. So in this switch statement, with letter grade being the controlling expression, the three cases A plus, A, and A minus are processed exactly the same way. Of course, you can copy the statement in the case A plus to case A and case A minus. But sometimes there may be multiple statements in each case, and copying them to other cases is not optimal and may make the code look bonky. Before JDK 14, you can use the following through behavior to combine these cases. By placing them in consecutive case sequence and place the statement for each case only in the last case block in the sequence. For example, here you can remove the statements for case A plus and case A. In JDK 14 and later version, these cases can be combined using the commas. So instead of writing case A plus colon, case A colon, then case A minus, as in the code above, you can just write case A plus, comma, A, comma, A minus, as in the example below. To avoid the errors from forgetting break statements in switch, JDK 14 introduced a new arrow operator, which is denoted by the minus sign followed by a larger than sign. So in JDK 14 and later version, you can use the arrow operator to replace the colon operator in a switch statement. With the arrow operator, there's no need to use the break statement. When a case is matched, the matching statements are executed and the switch statement is finished. For example, to correct the switch statement in the previous example, which is to convert a numeric day to a name of days, we can replace the colon after each case label with the arrow operator. Then when the day variable is assigned to 1, the switch statement outputs Monday as expected because case 1 is matched and the switch statement finished after the statement for case 1 is executed. There are two limitations of the use of the arrow operator in a switch. First, it cannot be mixed with the traditional colon syntax within the same switch block. For example, if we use the colon syntax for case 1 and use the arrow operator syntax for case 2 and case 3 in this switch statement, we will get a syntax error. The second limitation of the arrow operator is that for multi-statement case block, the curly braces are required. For example, if you use the arrow operator after the case label plus in the calculator program, and you have two statements for this case like this, then you have to enclose those two statements in a pair of braces. Another new feature introduced in Java 14 is the switch expression. The syntax of switch expression is similar to that of switch statement, except that the statements in each case must be replaced by an expression or yield a value. So a switch expression returns a value. The switch expression in this example returns a string. For example, when the variable day is equal to 1, it returns the string Monday. When variable day is equal to 2, then it returns the string Tuesday. When day is equal to 3, then it returns Wednesday. And in any other cases, it returns just the string that consists of one space only. And because it returns a string, you can embed this switch statement in any place that accepts a string. For example, in the argument of the println statement. So this println statement is equivalent to the switch statement, which has the same controlling expression day and prints the string Monday for case 1 and prints Tuesday for case 2 and prints Wednesday for case 3 and a space for all other cases. Note that a switch expression must cover all cases, but a switch statement does not have to cover all cases. In this example, the default case is required to cover the integers not listed in the case labels here. The break statement is used to skip the remainder of a switch statement, as we have seen. The break statement can also be used in a loop. When executed in a while, for, or do while loop, the break statement causes immediate exit from the loop. Execution then continues with the first statement after the loop. For example, suppose we want to write a loop to read in a list of non-negative integers from the keyboard until the users enter -1. In this while loop, the loop continuation condition is true, which means it would be an infinite loop if there's no way to break out of it. In the loop body, it first reads the number and then checks if the number is -1. And if so, it executes the break statement. If not, it adds number to the variable sum, which is initialized to 0 before the loop. In a sample run of this code, the user enters numbers 10, 5, 20, and -1 during the loop execution. When the user enters -1, the break statement executes, causing the loop to terminate right away. The statement sum plus equal number in the loop body is skipped after the break statement executes. So the value of sum doesn't include adding -1. The program continues with the first statement after the loop, which prints out variable sum. Here is an example of a statement in a for loop. Just like in a while loop or do while loop, the break statement in a for loop will cause the loop body to terminate immediately, and the program continued with the first statement after the for loop. In this example, the for loop uses the variable count as the control variable and is iterates with a count from 1 to 10 and displays the value of count in each iteration. But when count is 5, it breaks from the loop before printing out the value of count. So it ended up printed out the value of count from 1 to 4. The update action that increases count does not execute after the break statement executes. So the value of count after the loop terminates is 5. Another statement that can change the flow of control of a loop is the continue statement. When executed in a loop, the continue statement skips the remaining statements in the loop body and proceeds with the next iteration of the loop. In while and do while statements, the program evaluates the loop continuation test immediately after the continue statement executes. For example, consider this while loop, which reads three positive integers from the keyboard and calculates the sum of all three numbers. It uses variable count as the counter variable. Variable count is initialized to 1 before the loop, and the loop continuation condition is count less than or equal 3. In the loop body, the first statement reads an integer into variable number. Then there's an if statement that checks if number is less than or equal to 0, and if so, it executes the continue statement. The remaining statement in the loop body add number to variable sum and increase variable count by 1. When this loop executes, and suppose the user enters number 1 and 2 in the first two iterations of the loop, and enters -3 in the third iteration of the loop, then the continue statement executes in the third iteration, skipping the remaining two statements of the loop body. So number -3 is not added to variable sum, and variable count is not increased in the third iteration. The program proceeds with the fourth iteration, checking condition count less than or equal to 3 again, and then executes the loop body for the fourth iteration. Suppose the user enters number 7 in the fourth iteration. Then the loop terminates and displays the sum, which equals the sum of 1, 2, and 7, not include minus 3. Here is an example of the continuous statement in a do-while loop. This example is the same as the previous example of the continuous statement in a while loop, only changes the loop from while to do while. So the behavior of the continuous statement in this loop is the same as in the while loop. When the continuous statement executes, the last two statements in the loop body are skipped, and the program proceeds with checking the condition count less than or equal to 3 for the next iteration. In a for statement, after the continue statement executes, the update action executes, then the program evaluates the loop continuation condition. For example, consider this for loop, which is the same as the for loop in the example with the break statement. But here the break statement is replaced with the continue statement. This for loop uses variable count as the control variable, and it iterates with count from 1 to 10 and displays the value of count in each iteration. But when count is 5, it continues. So it skips printing out the value of 5 of the variable count and moves on to the update action, which increases count by 1. In the subsequent iterations of the loop, the variable count never receives the value 5 again, so the continue statement doesn't execute again, and the loop prints out the value of count until the loop continuation condition is false, that is when count is 11. So after the loop, variable count has value 11, and the loop displays all values of count from 1 to 10 except for value 5. At this point, we have covered all control structures supported in Java. Let's summarize them. First, recall that only 3 control structures are needed to implement an algorithm. They are sequence, selection, and repetition. The sequence structure is trivial. Simply list the statements to execute in order in which they should execute. The the selection structure can be implemented in one of 3 ways: by the if statement, which is known as single selection, or by the if else statement, which is known as double selection, uh, or by the switch statement, which is also known as multiple selection. The repetition structure can also be implemented in one of 3 ways: using the while statement, or the do while statement, or the for statement. The do while statement always executes the loop body at least once. The fourth statement is the natural counting loop. All these structural statements can be combined in only two ways, by stacking or nesting. However, we don't need all the structural statements supported in Java. Any form of control ever needed in a Java program can be expressed in terms of sequence, the if statement, and the while statement. The simple if statement is sufficient to provide any form of selection because everything that can be done with the if-else statements and the switch statement can be implemented by combining the if statements. The while statement is sufficient to provide any form of repetition. Everything that can be done with do while and for can be done with the while statement. Java also provides the break and continue statements, which change the flow of control of the loop where they are in. Using break and continue statements can simplify programming in some cases, but overusing them can make programs difficult to read and debug. Now we move on to the last section related to control structures, which is about logical operators. Recall that every selection or repetition statement requires testing a condition. Conditions are Boolean expressions which return Boolean values. But in our example so far, we have used only simple Boolean expressions, such as comparisons, as conditions. To form complex conditions from simpler ones, we can use logical operators, also known as Boolean operators. These operators operate on Boolean values to create a new Boolean value. Recall that there are only two Boolean values, true and false. Here is the list of common logical operators. The first one, which is denoted by two ampersands, is the conditional AND operator, which is also called logical AND operator. It is a binary operator and returns true if and only if both of its operands are true. The second operator is denoted by two vertical bars and is called conditional OR, which is also known as logical OR. It is also a binary operator and returns false if and only if both of its operands are false. So it returns true if one of its operands is true. The last one is the logical negation operator, which is also known as the logical NOT operator and is notated by an exclamation point. The logical NOT is a unary operator that has only one Boolean value as an operand. It is placed before its operand and returns the opposite value of the operand. So if the operand has value true, then the logical NOT op operator will return the value false and vice versa. The logical AND operator has higher precedence than the logical OR operator, and both operators associate from left to right. Let's consider a program that demonstrates an example of using logical operators. This program first prompts the user to an, uh, enter a year as an int value and checks if it is a leap year. As a matter of fact, a year is a leap year if it is divisible by 4 but not by 100, or it is divisible by 400. In order to test if a number year is divisible by 4 or not, we take the remainder of year divided by 4 and compare it to 0. The value of year is divisible by 4 if and only if the remainder of year divided by 4 is equal to 0. So this expression in Java is a Boolean expression that means year is divisible by 4. To express that year is divisible by 100 or 400, we just replace 4 in this expression with 100 or 400 respectively. So we have three simple Boolean expressions which express three conditions. Year is divisible by 4, year is divisible by 100, and year is divisible by 400. Now we use logical operators to combine these three simple Boolean expressions into a new one that expresses that year is a leap year. The condition that year is a leap year is a logical OR of two Boolean expressions. The first one means that year is divisible by 4 but not by 100. And the second one means that year is divisible by 400. So we simply put the expression year percent 400 equal 0 as the second operand of the logical OR operator. The first operand of the logical OR is an expression combined by the logical AND of two Boolean expressions. The first one means year is divisible by 4, and the second one means year is not divisible by 100. To represent the expressions that year is not divisible by 100, we just put the logical NOT operator before the expression that means year is divisible by 100. So this is the anti-expressions that express that year is a leap year. Now I'm going to show examples of evaluating logical operators. Suppose we have these variable declarations, okay? And here we have 4 Boolean expressions. Okay? So these are complex Boolean expressions, not just a simple one. And we can assign each of these Boolean expression to a Boolean variable. Okay? And so then when each of these Boolean expressions is evaluated, the result, either true or false, will be assigned to the Boolean variable in the left hand side of the equal sign of the assignment. Okay, so in the first one, it is just the logical AND of two Boolean expression, and both of them are a simple one. They are just comparison. Okay? The first one is that age is less than or equal to 21, and the second one is weight larger than 90.0. So the variable age is having the value of 20. So the first operand of this logical AND is true. Okay? And the second one, which is weight larger than 90.0, is false because weight is equal to 85.7. So the result of this logical expression is false. So in the second one, it is the logical OR of two operands. The first operand is the logical AND of two operands. That is, so this one means that n is not equal to 1 and n is not equal to -1, which is true because n is equal to 10 at this point. And the second operand of this logical OR means that n is an odd number because it takes n divided by 2 and compares the remainder with 1. Okay, so an odd number could have the remainder when divided by 2 to be 1. Okay, so this one is false. The second operand of this logical OR is false, but the first one is true. So the result of the anti-expression is true. In the third expression, it means that answer is not the little y and sorry, in this expression, it is a logical OR, not the logical AND. And so this anti-expression means that answer is either little y or capital Y. And answer is a variable of time char and is having the value, which is the character capital N. And so both operands of this logical OR is false. So therefore, the result of the anti-logical expression or Boolean expression here is false. Well, so in the last one, we have variable c, which is also a time char, and we apply a logical NOT to the anti-expression, which is a logical AND, right? So the logical AND combines the comparison that C is larger than or equal to the character 0, and C is less than or equal to character 9. So the expression of this logical AND means that C is a decimal digit. And then we apply the logical NOT to this anti-expression, then that negates that expression. So this anti-expression with the logical NOT here means that C is not a decimal digit. And right now C is assigned to the uh, digit 0, okay, the character 0. So this one is true. So and this one, which is C less than or equal to 9, is also true. So the result of this logical AND is true, and then when you apply the logical NOT to true, you get the value false. All right, so this is a small practice for you to get yourself familiar with logical operators. So in this practice, I like you to convert each of these two conditions into Java Boolean expressions. Okay, so here in the first one, it means that x is larger than or equal to y, which is larger than or equal to z. So here x, y, z are int variables. And the second condition means that C is an uppercase letter, where C is a variable of time char. Right? So these conditions are expressed in English and mathematical notation. You need to convert them into Java Boolean expressions. Okay, so try yourself first and then go back and see the solution here. Okay, so now it's time to review the solutions to this practice. For the first condition, many students may attempt to have the wrong answer by just simply converting the less than or equal to sign in mathematics into Java notation like this one. So note that this is a wrong answer because when you write this expression, Java will first evaluate the comparison between x and y. And this comparison results a Boolean value. Okay? And then they evaluate the second comparison. So in this case, it would compare a Boolean value with an int value. And that's not allowed in Java. So therefore, in this case, you will get a syntax error. The correct answer is to use the logical AND operator, uh, with the first operand being the comparison but that x is larger than or equal to y, and the second operand being y is larger than or equal to z. For the condition 2, right, so to express that C is an uppercase letter, we just need to make sure that C is between the character capital A and uh, character capital Z. So here we just need to use a logical AND to compare C with capital A and to compare C with capital Z. By the way, I like to show you how to display a Boolean expression's value as a word true or false when you try to output them. So the answer is very simple. You just need to use the %b format specifier. For example, so here we have the Boolean variables result 1, result 2, result 3, result 4, as in the previous example. Okay. And so now we want to print out the values of these 4 Boolean variables. And to do that, we just need to use the %b inside the printf format string. And in the second part here, we can write the expression directly in the argument of printf instead of using a Boolean variable. But here we also use the %b, and so here is the expression, the output of the expression. The logical and logical OR operators have another feature called short circuit evaluation. This feature mandates that operands of these operators are evaluated left to right only until the value of the combined expression is known. So not both operands of this operator are always evaluated. That's why these two operators are also called conditional and conditional OR operators. For example, consider the first expression, which is the conditional and of two operands. The first one is x larger than or equal to 0, and the second one is y larger than 1. So if the variable x is less than 0 before this logical AND expression is evaluated, then the first operand of the logical AND is false. So then Java will not evaluate the second one, which is y larger than 1. So similarly, if we replace the logical AND with the logical OR, and in this case, so we know that if one of the operand is true, then the entire expression of the logical OR is true. So if the variable x has a value larger than or equal to 0 before this logical OR expression is evaluated, then Java also skip evaluating the second one, which is y is larger than 1. This feature can be applied to avoid division by 0. For example, uh, if we want to express the condition that x is not if we want to test if 10 over x is equal to 2 or not, but if x is equal to 0, this would give you a division by 0 error. So we add the condition x is not equal to 0 as the first operand of the logical AND operator, and place the expression that 10 over x is equal to 2 as the second operand. So in this case, if the first one is false, that is x is equal to 0, then the program will not evaluate the second one, which would take 10 divided by 0, and so it will avoid the division by 0 when x is equal to 0. However, be careful with increment operators. For example, if the second operand of the conditional AND or conditional OR has some side effect, for example, like increment or decrement operator, like this one, then in that case, it may cause a logic error. Java also has three other logical operators that are also bitwise operators. These operators can apply to Boolean operands and return a Boolean value. And they can also apply to integer operands and return an integer value. The first operator is denoted by 1 ampersand and is called unconditional AND or bitwise AND operator. The second operator is denoted by one vertical bar and is called unconditional or bitwise OR operator. The unconditional and unconditional OR operators are the same as the conditional and conditional OR operators, except that the unconditional and unconditional OR operators do not perform short circuit evaluation, so they always evaluate both of their operands. This is useful if the right operand has a required side effect, that is, a modification of a variable's value. The last operator is denoted by the caret symbol, and is called exclusive OR operator. This operator returns false if and only if its Boolean operands have the same value. In particular, applying exclusive OR on two true operands yields value false. So it returns true if and only if its operands have different values. One is false and one is true. The exclusive OR operator is guaranteed to evaluate both of its operands. Note that these operators are rarely used as logical operators. They are used more often as bitwise operators. Finally, I want to mention an error prevention tip related to Boolean expressions. In Java, the single equal sign is used as the assignment operator, but many beginner programmers tend to mistake it as the equality comparison operator, which is denoted by two equal signs. The equality comparison operator can be used in conditions, but the assignment operator should not. Every condition must result in a Boolean value, otherwise a compilation error occurs. When you use an assignment in a condition, it will compile only if a Boolean expression is assigned to a Boolean variable, such as in the first example here, where the assignment b equal false is used as the condition of the if statement. But in this case, it changes the value of variable b from true to false, which may cause a logic error later in the program. If the assignment used in a condition assigns a value to a non-Boolean variable, such as an int variable, then a compilation error occurs. In such a case, it would help you check if you accidentally use an assignment in place of an equality comparison. So that's the end of this video, which is also the end of control structures in Java. Thank you for watching, and I hope you continue to practice in order to be good at programming. And see you in the next video, which will be about methods in Java.